Hello everyone. So now we'll discuss the next method of limits, and the next method, I think this is fifth or sixth method, 1 to the power infinity form. 1 to the power infinity form. This is also one of the indeterminate forms as we have discussed. Okay, and as I have told you, in the 1 to the power infinity form, this 1 is actually not 1. Okay, as we have discussed this thing, this 1 is not 1, because if you have something like this, x to the power infinity and x equal to 1, then this will become 1 only, because 1 into 1 into 1 is 1, as you know. So it doesn't matter how many number of times you multiply, this will give you 1. But the indeterminate form is when you have something like limit x to the power infinity and x is tending to 1. X is tending to 1. Now this is the indeterminate form. This you have to remember. Here x is not 1, x is tending to 1. Why? Because for right hand limit, okay, x will tend to 1 plus x will be greater than 1, and you have x to the power infinity. When you have some number, some value greater than 1, and you are increasing the power, the value will increase. You know that, you must be knowing that. Okay, you have 1.1, you will square it, 1.21, the value will increase. You will take the cube, the value will increase. Okay, so that's why this will tend to infinity. But while finding left hand limit, okay, you have x tends to 1 minus less than 1. Here the value is less than 1. So now the value is less than 1. Let's say, for example, I take 0.9. Okay, I take the square of this x square. Okay, 0.81. The value will decrease. I take cube 0.7 something. Okay, the value will decrease. So this will keep on decreasing. And as I take the power to be infinite, very large, very large, this will become 0.0000000, so many zeros. Okay, means will tend to 0. So this thing you have to remember. Okay, for right hand limit this will give you another result, for left hand limit this will give you other result. Okay, that's why we say this is indeterminate form. Indeterminate form. Not when x is equal to 1. When x is equal to 1, this will give you 1. Okay, it doesn't matter how many number of times you multiply. Okay, so first of all you have to understand which is indeterminate and which is not indeterminate form. That you have to understand. Okay, and when the form is clear to you that you have the indeterminate form, and you have to find the limit. Limit has to be something like limit fx to the power something. Okay, and x must be tending to some value, let's say. And this is 1 to the power infinity form, means here fx is tending to 1, not equal to 1, you have to remember. And gx is tending to infinity, sometimes minus infinity, that can happen, it doesn't matter. Okay, for both the values the result will be same. Okay, so first of all this thing has to be clear. Now how to solve, what is the result? The result is very easy, very simple. Okay, the result is very easy, very simple. If you have this form 1 to the power infinity, then you can write this limit equal to x tends to whatever is the value a, e to the power gx exponent into fx minus 1. This is the result. You have to use this result and the limit will be solved. Okay, now you have to, this is the base e which is fixed. You have to use limit here. Here you have to use limit, and you can use any method because fx is tending to 1, so 1 minus 1, this will tend to 0, this value will tend to 0, this is tending to infinity, so you have infinity into 0 form. Infinity into 0 form you can solve easily. So many methods you have. You have factorization, you have rationalization. Okay, even you can use L'Hopital by converting into 0 by 0 or infinity into infinity form. Let's say I take infinity in the denominator, so this will become 1 by infinity will become 0. Okay, or if I take this 0 in the denominator, so infinity upon 1 by 0, 1 by 0 will give you what? Infinity. So we can convert, and now you can use L'Hopital method. Okay, now the point is, how come this result, from where we finding this result? Okay, so we'll discuss that. Before deriving this result, we'll give you 1-2 examples. Okay, problems are very easy. Just okay, I want to make you understand that problems are very easy. So I am just writing one example, like you have limit x tends to 0, 1 plus sine square x, okay, to the power 1 by x square, right? Okay, problems are very easy like this, which are asked in IIT, in JEE mains, JEE advanced. Problems are very easy. Once you have to understand this is 1 to the power infinity form. Okay, then you can use this result. This is the result. Okay, so you will write e to the power limit x tends to 0, e to the power gx into fx minus 1. This is fx minus 1. So what do you get? Sine square x. Okay. Now you can use the earlier result, sin x by x, x tends to 0, limit is 1, you know that. Okay, so you can use that, right? So this will become e to the power 1 square, that is 1. So this is e, right? Okay, we are using this result. X tends to 0. Okay, the limit of sin x by x is 1, you know that, right? In school you have to write limit everywhere. Okay, don't forget that. Anyways, the problems are very simple like this. We will discuss few problems of IIT. All the problems are very easy. Before that, we'll understand from where we getting this result, right? So let's derive this. Come to the derivation part. So you have this limit. Let's say we don't know what is the result for this. Okay, this fx is tending to 1, gx is tending to plus or minus infinity, and we don't have any result. Let's say assume. Okay, so what we will do? 1 to the power infinity form. So when the limit is also in exponent in the power, okay, you have some function. So what you can do is, to remove the power, what you can do is you can take log, right? So I am taking log. So log n. Okay. So limit is the limit. Okay, right outside. Log of this thing, fx to the power of gx. log of this. So what you will get? Okay, gx into log fx. This you will get. Okay. Now fx is tending to 1, so log 1 will tend to 0, and this is tending to infinity. So basically right now you have infinity into 0 form, indeterminate form, and you want to solve this, right? So what we'll do, keeping that result in mind, we'll tell you what is the result. Gx into, will write, in place of fx will write log 1 plus fx minus 1. 1 plus fx minus 1. Okay, adding 1 and subtracting 1. Why? Because this value fx minus 1, fx is tending to 1, so fx minus 1 will tend to 0, right? And we have that result. Which result I am talking about? We have the result log 1 plus x by x, x tending to 0. This limit is, we know this thing, this limit is 1. We have this result in mind. Okay. So in place of x, you have this fx minus 1, which is tending to 0, quite like this result. So what you have to do is, you have to divide and multiply. Okay. So we'll write limit x tends to a gx into log 1 plus fx minus 1, right, divided by fx minus 1 into fx minus 1. This you have. Okay. Now this value is tending to 0. Okay. So it is similar to log 1 plus x by x, x tending to 0. Okay. So this limit of this part, this much part, is what? Is 1. Okay. So what will be left? This gx and this fx minus 1, this will be left. Okay. So we get right here. We get log n is equal to limit x tends to that value a gx into fx minus 1. This. Now this is very much simplified. Okay. And this gx is tending to infinity, fx is tending to 1, so 1 minus 1 0. Now you have 0 into infinity form, which you can solve easily by using so many other methods, factorization, rationalization. Okay, I'll have to using the results like the way we use here the result. Okay, so many ways. Now I have to write L, so I have to remove this log. So to remove this log, what we'll do, we'll take antilog. Okay, so taking antilog of this, what we'll get? E to the power this. Okay, limit you can write anywhere, so I will write outside. So e to the power, base is e, obviously, natural log this is, e to the power this thing. Okay, so this is the value of limit I am getting, right? And here we have taken the anti-log. So if anybody is having any doubts, and then log y is equal to x, base a means y is equal to definition of log. If we remove log, what we get? A to the power x. This is the thing we are using. Okay, here base is e, so e to the power this thing, right? So this way we get this result. I think now things are clear. Okay, so now come to the examples. Some problems of IIT JEE we'll discuss. Okay, so our first column is this. Problem of JEE Mains 2016. The problem was like this: 1 plus tan square root x, okay, whole to the power 1 by 2x or 3x, I don't remember. 2x, let's say. This was. Okay. And x is tending to 0 plus, actually domain you can understand, x has to be positive, so x was positive, 0 plus. So now you can see this will become 0, this whole thing, this base will tend to 1, and power will tend to 1 by 0, infinity. So this is 1 to the power infinity form, our form. So we can apply this result. The result is right there. So we can write limit x to the power 0 plus, okay, e to the power this 1 by 2x gx into fx minus 1, this minus 1. So what do you get? Tan square root x. Okay, and now you know the result. Result is tan x by x. X tends to 0. Limit is 1. You know this thing. So we'll use this result. Okay. So equal to limit x tends to 0 plus tan square root x divided by 2 into this x, I can write the square root x square. Okay, so here we get this form. Okay, sorry, e to the power, e to the power, base is right. So limit of this is 1, so 1 by 2, e to the power 1 by 2 is the answer. Simple, just 2-3 lines it takes. Okay, in most of the problems, more than 90% times in limits, it just takes 3-4 lines, that's it. Okay, we'll come to the other column of IIT Advanced 2011, I think. The problem was like we had to use this limit somewhere to solve one equation. 1 plus x log 1 plus b square whole to the power 1 by x. Okay, so you can see this is 1 to the power infinity form, so we'll use this result. So what do you get? Limit x tends to 0, e to the power gx 1 by x into fx minus 1, so x into log 1 plus b square. This x will cancel out, so what do we get? E to the power log 1 plus b square, and this thing will be simplified. This thing will become 1 plus b square. Right? Come to the other problem of IIT 2000, I think. The problem was like this: limit x tends to infinity. Okay, x minus 3 by x plus 2 whole to the power 1 by x. Okay, this was the problem, I think. Right? Whole to the power x, x. This was the problem. Okay. So again, this is the problem of IIT, so it has to be easy, not difficult. Now, this is infinity by infinity to the power infinity form. This is the form you get in. But when we simplify this thing, you know the limit of this thing. Okay? X minus 3 by x plus 2, x tending to infinity. This, you know, a naught by b naught, that is 1. Okay, infinity by infinity form. So ultimately, this is 1 to the power infinity form. So what we'll do, we'll use that result we had just written here. Okay. So limit x to the power infinity e to the power this gx into fx minus 1, this minus 1. So this minus 1 will simplify. What this will become? E to the power x into, this will become minus 5 by x plus 2. Okay, this is the constant. Now x is tending to infinity, so this is infinity by infinity form. And for this thing, if we use the limit, you know, the limit for this thing, x by x plus 2 will tend to, for x tends to infinity, a naught by b naught. Coefficient of x divided by coefficient of this x, that is 1. Okay. So this will become, we put the limit, e to the power minus 5 by 1 means e to the power minus 5. So such are the formulas. Same way, you can solve one more problem, you can solve easily. That was the problem of 93, I think. That was limit x tends to 0, okay, tan pi by 4 plus x to the power 1 by x. This was the subjective problem of IIT 93. You can solve easily by using that result. Then using the formula of tan a plus b. Okay, you know tan a plus b is tan a plus tan b upon 1 minus tan a tan b. And the value of tan pi by 4 is 1. You know that. We'll use that. You can find it. Okay, right? So see you in the next class. And in the next class, we'll discuss sandwich theorem. Or you can say squeeze play theorem. Right? Okay, bye.